Good afternoon. Welcome to our presentation, everyone, on cloud-native data applications at scale. And hopefully by example, the demo gods haven't been too kind to us, so let's see what we get. My name is John Blum. I'm with Pivotal, and I'm a member of the Spring team, specifically working on Spring data. However, excuse me, I do work across the Spring portfolio on other projects like SpringBoot, Spring Session, and probably some other Spring projects that you're familiar with as well. And with me today, I have my good friend and colleague, Luke Shannon. Luke?
My name's Luke. I work for a company called Phlyt. We're a partner of Pivotal's, specializing in Spring, Geode, Cloud Foundry.
Cool. Thank you, Luke. All right, so we've been doing this talk for a while now, and each year we try to improve it based on the feedback that all of you give us, and we appreciate that. So I want to start off a little bit differently this year by saying, first of all, thank you for being with us today in our talk. I know you have a lot of options in lieu of this conference. There's a lot of other, in lieu of all the other sessions and content that goes on. Thank you very much for being with us. But also because we're constantly trying to improve this story, I also want to say that, and make it clear that we're not here to tell you what to do. We're really here to share our knowledge and our experience and hopes that it will give you ideas on how to do what you do better and more effectively. Because after all, you are the experts in your problem domain. Nobody can tell you what's right or wrong. And part of the reason for that is, well, technology is constantly changing. Our requirements, our use cases are constantly changing. Our audience is constantly changing. Everything is constantly changing. And if you've been in the industry long enough like I have, and I'm sure a lot of you have, you see these cycles that occur in technology. The old becomes new again, right? It's different. It's better this time around, but it still has that similar feel to it. And that's not uncommon, right? Like we see that a lot in technology, and that's because we're trying to build on the shoulders of giants. And every idea starts off with good intentions. It starts off simple, easy, it's fun and exciting. But over time, it gets more complicated and harder to keep the boat afloat. And so we have to tear everything down and kind of rethink things and start again. And I would say nowhere is that more true today than in the cloud, right? The cloud's really exciting. There's a lot of things you can do. You can push applications up in an instant. You can connect all these amazing services, and you can do really powerful things, amazing things, right? It's no longer the Hello World applet that you deployed in your browser years ago if you were using Java and it maybe had a fancy graphic. It's these really sophisticated applications that do amazingly powerful things in real time. However, the cloud's not an exception to the change, right? Everything goes through change. Everything goes through those cycles, and there's growing pains along the way. So the cloud's rather unpredictable, and it changes quickly. And it's downright scary, right? And, well, things can go wrong. And when they do, we panic. An instant fear kicks in because our service isn't available, we can't reach our customers, and we have problems. Which isn't unexpected, of course, but invariably we always ask the question of, what went wrong? Where did it go wrong? Why? How do we fix it? How do we avoid this going forward? And part of it is just being prepared going into it in the first place. So there's a lot of technology out there today, a lot of good resources online. You can go and read about the 12 factors, right? The methodology there behind that. There's a lot of books, a lot of people to talk to that have done these things, like Netflix. We've heard from those folks. A lot of other really great companies as well. And when you begin that journey to the cloud, we're told one of the first things you want to do, of course, is break everything down into microservices, because it's easier to manage, right? Less is more kind of thing. We can keep things really small, and if it fails and breaks, like we don't want that to propagate. We can keep these things resilient. We can scale those things out. We try to treat those things as non-pets, like we don't want them to become our pets or partial to these applications. But, so there's all these guidelines and things that we can do, but there's no really good guides on when something goes wrong, how do I fix this problem? There's no book that says, here's how you fix your exact problem. You go on Stack Overflow, you hope that somebody might have seen this type of problem before. You ask a question, you hope that they have answers that ultimately help you. That's why those forums exist in the first place, because there's not one consolidated content for every single problem you might have, because it's always changing. So that's one of the things I wanted to kind of focus on today, was talking about some of the problems that you may not expect, or you've seen, right? You have seen these things, and some of them are quite common. Actually, as I was developing the slides for this, I was thinking to myself, man, there's so many more I could have talked about, but we only have so much time too. So I want to focus on one particular instance of the application, and one aspect of cloud-native microservices, our scale, right? When we scale these things out, they're stateless. We should be able to scale them up. They should be able to come and go. They should be disposable. And they're really self-contained, so the resources that we connect to, like that's a logical unit, and nothing interfaces to the resources except through our APIs, our apps. So what are some of the problems that we could actually run into with this sort of design? Probably the most obvious one is we can have network problems, right? Network is always going to be one of the #1 factors in all the problems that you're going to see. Couldn't connect to some service. And that might be internal to our application, like we couldn't connect to our database for some reason. But it's not just our applications talking to its internal resources. It's our applications talking to other resources, external resources, a lot of other resources, other microservices. And so when you have network problems, this problem can cascade, right? So you have to be kind of resilient to that failure. And of course, there's frameworks out there to address these sort of concerns, but you have to know how to use these things effectively. So it becomes a lot more difficult of a problem to solve, especially at scale. But if we step back for a moment, what are maybe some of the other problems we might run into? Like, this is just a single microservice that we've scaled up. It's awesome when all the microservices agree on what the data is. It isn't so awesome when they don't agree what the data is, right? So we might have some consistency issues. I worked with T-Mobile earlier this year who had like 200 different Kubernetes clusters with an application that spanned across all those. And they cached a lot of things in their session, and they saw consistency problems, right? Very common. Load, of course, is always a concern. It's not just web browsers anymore. It's mobile devices. It's Internet of Things. It's all these things that are accessing our applications. So that's obviously a concern. And what we instinctively do is we go to the technologies that we're most familiar with initially, right? Like we adopt, like Redis, for instance, for caching, right? We might actually throw in MongoDB if we have RESTful services and we want to store documents. We might be using serverless, right, on whatever platform that supports that particular architecture. We might have these functions that are short-lived. We might have search use cases. We might look at our data a little bit differently than if we were just writing normal queries. We need to be able to, maybe do certain type of searches. And then, of course, today, no architecture is complete without Kafka. Everybody's using Kafka. But on top of that, now you need Docker to kind of manage all these individual services. Like, we need to containerize that so that a failure in one service doesn't bring down all services, right? All machines. And then you need a way to manage all your Docker containers, so you throw in Kubernetes. And then, well, to make Kubernetes easy, you need a platform to do that. And then everybody's kind of vying for your attention, right? You've got all the vendors that are trying to offer you services and products to make all this stuff easier to do. And then there's always the 800-pound gorilla in the room that pretty much rules them all. So what we're left with is just an enormous amount of complexity boiling in the ocean, trying to solve maybe a rather simple problem. And so complexity is just off the chart. So how might we solve that problem? Well, I've already kind of spilled the beans a little bit. Less is more. If we can find out a way to do more with less, then that's easier to manage, right? If I have one service versus 2 different types of services to manage, that's easier, theoretically. So it's finding ways to reduce our footprint a little bit, reuse our existing services, and to extend those services, to find solutions that actually can do more than maybe one particular concern, like just caching or something like that. Can this extend into other spaces? Can I prolong the life of this, right? Can I get more return on my investment, essentially? So how might we do more with less? Well, if we go back to this diagram a little bit, we might be able to replace it with a different technology. I'm assuming that most of the people that are here know of Apache Geode. Maybe you went to the Geode Summit. I hope you did. Fantastic technology. It's amazing. It can do quite a bit. It can do caching, for instance. Maybe you're already using Redis. That's fine. But you can use Geode to do caching as well. You can use its serialization mechanisms to actually ingest documents and translate that into a format where you can actually query it. We call this PDX, Portable Data Exchange. So it basically transforms those documents into a serialized format that you can query, you can do functions on, and you can actually write that back out to JSON as well. You can integrate with Apache Geode's integration with Lucene, for instance. You can do search use cases on data that's kept inside of Apache Geode. You can replace maybe your serverless architecture with something like Apache Geode's function executions, which is really powerful, right? Rather than bringing all your data and processing it, we send the logic to where your data is, and you can distribute that data, partition it, make it redundant, make it highly available. That's a lot more efficient than trying to bring all that data back and process it and transform it kind of in a linear pipeline. And finally, you can even use event stream processing to do some of the things that you could do in Kafka. You can create what's similar to topics and register for those events and get those things. Now, I'm not saying that Geode is a replacement for everything here. You can, in fact, use it as a system of record, but this isn't an or problem, it's an and. So you can start combining some of your existing technology with something like Apache Geode and use it in parallel, in conjunction with each other, and maybe over time shift some of those responsibilities over to something like Apache Geode. And what makes it really easy to do is you have this awesome framework to make that integration simple, both for your use cases as well as the technology you might integrate with, like between Redis or a Kafka, for instance. Think of something like Spring Cloud Dataflow. But again, it isn't all about just replacing that technology. It's about an or. It's about an and, right? An and story. So as we scale out our application, historically, what we've done is we've scaled this guy up as opposed to, better yet, scaling him out. As we scale out our microservices to avoid some of those failures like network problems or resource overload, we also want to scale out our data technology linearly as well as a way to solve some of those problems with resource load. Excuse me. And we want to be able to do that easily. We don't want to have to manage all these things ourselves, because that's really difficult to do. Certainly during development, you want things to be simple and easy to set up and get going. But once you start venturing towards the more difficult use cases, production use cases, where we're all on that trajectory, we need something that can really simplify that. And PCC is another technology that's built on Apache Geode that makes it really simple to do. It's essentially all those things I showed in the last slide that can handle these different use cases in a managed environment that's with Pivotal Platform or just Cloud Foundry in general, and can tie everything together seamlessly, your apps with your services, right? Makes it more seamless to do. And part of what makes that possible is a framework and a technology, but the real game changer first is giving you the ability to move from that open source space, right? Starting small, starting simple, and moving to something that's managed in the commercial space, like a PC service instance, to move from a non-managed environment, maybe you're managing your own clusters initially, and then moving into a managed environment, and to do that with little to no code changes. Like you want that just transition to be as seamless as possible. And it should just work. And you should be able to go the other way. Because when you're developing applications and you're in a production environment, you don't always have the luxury of actually working with those applications in that environment, testing things and debugging things. So you need to be able to bring it back, right? You might need to come back to a non-managed environment inside your ID, testing things locally, running your debugger, maybe even going back so far as like using some open source components. Either way, it should just work. And the technology that makes that work is SpringBoot for and with Apache Geode as well as Pivotal Cloud Cache. These things are literally interchangeable. you basically include a starter on your class path, and you can move between these environments. And we're going to kind of show that later on, what that looks like. But as you're developing applications, it's important to focus on to have a mindset focusing on certain things in terms of how you would go about solving your problems. Like, how can I simplify my application and make it cloud ready, right? Especially at the data layer, where historically we've scaled up, and really what we want to do is scale out. Well, the most easiest and non-invasive way to actually use a technology like Geode is to start with caching. It's pretty much a no-brainer that everybody uses some form of caching, like, for instance, HTTP session state caching. That's very common, probably the most common use case of caching. SpringBoot for Apache Geode actually integrates with Spring Session, so you can use it as an HTTP session state provider. But there's also multiple forms of caching, right? Like, we think of caching like 20 years ago, like we think, well, we have this cache and it keeps the data in memory, and that's all it really is. But there's a lot more to caching these days. You have look-aside caches, which is what the Spring cache abstraction is. So Apache Geode PC is literally a provider for Spring's cache abstraction. But there's also things like near caching. And historically, you have your application as a client to some services, right? I can bring data locally to my application. That application can actually get updates notified in real time. It can actually go down, come back up, and pick up where it left off. There's all these different things that you can do with the near cache that makes your applications a lot more quick in terms of latency. There's other forms like inline and multi-site. Multi-site's really powerful because I can have active architectures or active-passive, one in standby, right? So caching is more than just a simple little in-memory solution. Some of the other patterns of cloud-native data access patterns, distributed compute, right? The value there, again, is not bringing data to where your logic is. It's taking the logic to where your data is, and having a platform that supports that particular combination is really powerful. Event stream processing. Everything is occurring much faster today, so we need this ability to be able to respond to things in real time, right? And what Apache Geode does is it allows you to register CQs, or these continuous queries, and it allows you a very expressive form of expressing what events you're interested in the first place by using query predicates. That's really powerful to do. And you get a callback, and the framework makes that thing easy to do. Or we'll see that in a minute. There's querying, right, and search. So we're starting to venture towards more advanced use cases, and then eventually system of record. Like, you continuously think about how you're moving towards, how do I supplant some of the legacy functions that my older data stores that weren't designed to be cloud scalable, how do we translate those into things that more modern stacks can do? So that's both easier and more effective. So this is kind of how it breaks down. You know, again, you start with caching because it's simple. You move into maybe distributed compute and event stream processing, which is still relatively non-invasive because there's not a lot of things you need to do from a schema perspective. And then you start getting into more advanced things, right? The data science-oriented things like querying, analyzing that data, processing it, going back to the functions, moving towards a system of record. So it isn't so much about, this graphics I kind of thought about, and I thought, this doesn't really represent it quite right. It's not about replacing the database. It's about augmenting it. Again, it's not an or, it's an and. Like, how do we use these technologies kind of in harmony together? But starting with a really minimal footprint initially, getting more mileage out of our things. So the SpringBoot project that I talked about, the Spring ecosystem that's trying to address some of these use cases like caching, distributed compute, event stream processing, it has auto configuration for these things. Spring's cache abstraction, Spring Session when it comes to HTTP session, Geode's PCC functions, CQs, querying and search with Spring Data repositories, right? We're starting to get closer to the system of record, but there's also other concerns that are equally important. You have to worry about the serialization of your data. When you're looking at client server, you have to send that data somewhere. So your data has to be serializable, and that's automatically auto-configured for you, so that your types don't have to implement Java IO serializable in the first place, which isn't the most efficient format. It's flexible in some cases, but it's not the most efficient. And also, you may not have the luxury of modifying certain types on your domain model. You might be using some third-party library that, those types aren't serializable in some capacity. So this sort of automatically just takes care of that concern for you, which is really nice. Also, authentication, security, that's very important today, right? So having some form of auto-configuration that makes your application secure out of the box is very important. So you don't have to fuss with all the permissions and worry about all the little details of making sure your socket connections are secure, that your apps are authenticating properly, and so on and so forth. So that's both the auth and the TLS SSL piece. And with that, I think it's about time for me to stop talking so much, and now you can all kind of take a nap and watch our demo. That may or may not work, so let's see what happens.
Cool. So we got a very simple application that we're going to quickly run you through, which works with a database. Simple SpringBoot app, and we'll cover some of the bits and pieces that it's doing, and then we're going to see what John can do to enhance it with Geode. So let's take a look at the application. So it's called Versus, and I'll create a little battle, and you guys can even vote on it. You do have to authenticate through Git, though. So let's check it out. So we'll just see how it works, and then we'll see the code and how it runs on PCF, and then John can enhance it. So this is obviously some test stuff that we're doing. So we'll just quickly create a new battle. We'll call it Best Hero. All right. And we'll create some characters. So I have some very unimaginative characters currently. Let's do some more known ones. All right. So there's Spider-Man. That's a very slow loading image. And we'll throw up Batman. Cool. So users can create characters, as you can see. And if you go to a battle, and we can view all the battles. So these battles are all closed. This one's still open, so I can vote on it. And it posts all the characters. We wrote this literally, over the last 2 days? So not 100% feature complete, but I'm going to vote for Spider-Man, personally. So currently, is somebody already on here voting? Someone voted. Okay. So, all right. Well, the battle's on, right? So a simple app. Are more people voting? I'm curious. Oh, I'm not allowed to vote twice. So let's see.
Error pages we haven't actually.
Yeah, we didn't do error pages. So let's go to view all standings. Okay, so it's a dead tie. All right, so super simple app. Let's take a look at the code. So SpringBoot app, 3 basic entities, which are battle and character. And we also have an entity called vote. So let's look at something a little bit more complex. So we're using Spring Data repositories, so it's pretty straightforward. So this is kind of an example of what you might see. Notice we're using the CRUD repository rather than JPA repository. John can talk a little bit about that. Got here the vote repository. Now, you'll notice we have actually a query here that is slightly more advanced than your general Spring Data accessors. So you can see we're doing some grouping, and we're using the JPA syntax to do that. So that took a little time to figure that out. But I mean, outside of that, it's super simple. If we look at another, let's look at character. I'm sorry? Can you zoom it? Oh, zoom it. I can do, whoa. Better? Yeah, cool. So pretty simple, and then we've got a controller layer, and we've got a service layer that sort of wraps some of the functions, creating characters, handling errors. One of our more complex services is the battle service. And we're going to share this code. It's a little messy right now, but we're going to clean it up and share this repo. So this one, you've got your typical gets and finds, but then you've got some more complicated things. So something like finding the winning character for all the votes. So we want to know who to put that little crown next to. So we get all the votes, but then we sort of have to do some logic here to figure out who the top vote is. And also we have some more methods to kind of figure out how the vote distributions are and who has the highest amount of votes per all the votes that there are. Now, sure, you could do some database stuff with this, but we found all the grouping on the just figuring out who the winner was kind of painful. So we sort of decided we were a little more comfortable with Java, and let's do some of this logic in Java. I mean, how many people have chosen Java over stored procedures in SQL? Yeah, pretty common, right? It's a lot easier to debug, and you can have test cases, and it's just a lot better. So our model was kind of like this, but obviously, there's a lot of code here in the application. Now let's see where this is running. So it's currently running on PWS. You can see we have this little versus application. And at present, we just have one service, which is our database. So simple CF push, hook up to the database, and we've got this app running. So I don't know, John, do you think Geode can help me out a little bit here?
Absolutely, absolutely.
Yeah? All right,
Should we take a look at some of that?
Yeah.
All right.
Let me ask you some questions while you're
Yeah, absolutely. And if
working
anybody
on
else has questions, by all means, please speak up. Part of the reason for doing this app is, as opposed to starting from scratch, and I want to actually start from scratch today, so we're going to do another demo after this one. But part of the reason for that is I feel like, based on all the customer interactions that I have, that while a lot of people are venturing into microservices and do a lot of awesome work there, that probably a majority of our time is still spent with maintaining those other applications that aren't microservices, right? Like we still have to keep the lights on, so we still have to keep those functioning. And what are ways that we can actually do that? So I'm going to jump over to my IDE. I do have the code base here available.
So quick update, Batman is up 5 votes to 3. And the X has a check mark. I keep having to refresh this page though, John, to check the results.
Yep.
Would Geode have something that could kind of help me with that by chance?
Yeah, definitely. Let's back up a little bit before we get down that path, and let's take a look at maybe a few areas in our application where we might be able to find some improvements. Now, caching is really good when you have read-intensive versus write-intensive type of operations. So essentially you're doing more reads than writes. You're doing a lot of reads, right? Like people are pulling information. If you think about going on the web, like Amazon, and searching for products, or maybe going through Netflix and searching for content, you're always constantly viewing information as opposed to like maybe mutating that information. You do, however, mutate stuff, so it's important to be able to keep in mind that your data is going to be transactional, but at the same time, you have, in a lot of use cases, I would say far more reads than you do writes. So caching is really good in those cases, especially when the input doesn't change or the output doesn't change for the given input. IDs, like if I look at my account, I log into my bank account, I want to see what my balances are, right? I'm giving it some sort of identifier. It's returning me that same object every single time. Now I might transfer some money, I might mutate something, but for the most part, I'm like maybe checking the balances of one or more accounts. I'm doing far number of reads. So if we look at the application code of our book service, for instance, I've added caching to several of the methods. Like we are constantly getting that battle back and viewing standings, for instance. So that's a good area for caching. The input, for any given input, the output is always going to be the same. Probably a lot of us know that already. What isn't maybe so apparent is, for instance, the votes. Like we want to keep track of the votes. And this is sort of happening in real time. People are using the app and they're voting for somebody. That's also a really good candidate for caching. I can keep that in memory and keep track of all those votes as they come in real time. And there's maybe 2 particular reasons why we might want to do that. One particular case is the function, right? Determining who the winning character is and being able to compute that, which means we're tallying up those votes. As Luke showed you in our previous service, I've actually got that here. Let's go back to that for just 1 second. In our previous service, we're using a query, and specifically where we're using this query, where we're basically saying, given a battle, go find all the characters for that battle, group them together, and do a count on their votes, and return that. So a lot of the work was being done in the database, and those kind of queries are generally pretty optimal, like you can get away with that. So that's not really maybe the best example, but it goes to show you that some of that logic got put into the database, and maybe there's perhaps better ways that we can do that. So one of the ways to do that, of course, is to use a function. So my data can be brought into that cache. So if we go back to the modern form of this method, the vote, we put some data into the cache, and then we find a winning character, we invoke this function, which basically fires out to the cluster, goes and looks at all the data for this battle, which might be distributed across multiple nodes. It might be redundant, right? So we can actually scale up our reads. We can make that really quick to do. And we can do the calculations where the data exists, aggregate it, bring it back, and bring us in the result. The nice thing about doing this with a function is that two things. I can do it in Java, so it becomes much easier to test. I don't have to worry about having some sort of store procedure or logic in the database. And I can actually enrich the data, right? It's because it's in Java, I can actually make calls to other APIs. I can use other services, maybe inside my function, to go out and pull in other data. I constantly think about, like when I'm playing golf on the golf course, and I'm playing around, I shoot a particular score. What was the weather like that day? What time of day did I play? How much did I spend, right? Like I think about, what other data you can derive from a really simple set of data. And so like these votes, right? Like we could find out who's trending. Like Twitter does a lot of this. There's a lot of APIs on Twitter where you can find a lot of information just by a simple tweet, So you can think of using it to enrich your data. And you also think about, like, it's an application code, something I'm familiar with. Not everybody is comfortable with SQL or store procedures. So the idea here is to actually cache that data in memory and then to be able to compute it with a function. And we can take a quick look at that function if you're curious. All this code is available, so you'll be able to take a look at it afterwards. This is the execution side, so we're actually using Spring for that. But on the server side, I actually used, where did I put that? I actually used the Gemfire API so that we could actually make this function more deployable to more environments. Here we go, function, execution, implementation. And you can kind of see that it kind of logically does what the JPA one did. Again, we're given a battle. We're going to get an instance of the query service, and we're going to run this OQL statement. So in a similar fashion with JPA, we are still counting all the votes for an individual character, but we're firing that off to all the nodes that have characters and votes for that battle. And right now, there's not a lot of data there, but you could imagine some votes, right? People voting on certain things. There's millions of people voting and millions of things happening. So distributing that data is absolutely critical from a performance standpoint.
And
but
how
it looks
would we
similar.
scale this? Would this be more scalable potentially?
Yeah, you could actually add nodes where your data gets partitioned to other nodes. You can make that redundant. So your scale is only really limited by the factor of how much you can scale out. Right? It's a shared pool of resources with memory, compute, even disk if you need it. That's distributed across a cluster of nodes that's doing that work in parallel for you.
So just to review, this is running on a Gemfire member.
This is running on a member that's hosting data for that particular region. And
right.
That region is a partition region that splits that data across a bunch of different nodes in 113 different buckets, right? So it also makes your writes optimal too, right? So it's kind of like the sense of a master-slave database where you always have to go through the master to keep your data consistent, but now you have more masters, in a sense, to write to, so you reduce your contention. But in this particular case, we're just thinking about it from the perspective of reading that data and looking at the subset of data that node's interested in and distributing that compute out to all the nodes and aggregate it and bring it all back. And as a result, we'd get much more scale that way. The final piece to this puzzle is another, okay, we're doing good on time, that may not be obvious is we have another component in the background there. So this is the whole caching and distributed compute thing. There's one more component of this application that wasn't apparent, and part of the reason why it's not apparent yet is because we haven't actually tied it into the application. This is very much a work in progress, but we actually plan to add some of these things, so we hope that you'll come back and check this repository out as it grows, and we'll be using it in future talks as well. So the other part of this application is dealing with eventing. So I also have another component here, a Spring component again, that registers a continuous query. And all I have to do is actually create a bean in my Spring application context that gets picked up by the container, and the framework will detect that I have a continuous query, and it will actually register that with the cluster and start it running. And I'll immediately get events. So I'm going to run this application locally just so we can kind of see that without any incident. and we don't have to switch.
So when you say get
environments.
events, my client is getting events from the cluster.
It is. So
Okay.
the SpringBoot application is connected up to this cluster. As people are voting, those events are coming in, and I could do
Into the cluster.
The votes are going into the cluster, and then my clients are receiving the information that people are voting, and I can do something interesting like update my UI and see the vote count change. Like we could see some of these things happen in real time. And you can respond to it however you want. That's applicable to your application use case, but you can get notified. The important thing here is that you get notified that something changed, something happened, and your application can respond to that and act accordingly. So this represents that. Basically, all I'm really doing is nothing really interesting here. I could make it more complex, like maybe I'm only interested in certain values, so I could actually add predicates here to my query. But in this case, I just want to see all the votes because I want to maybe update the vote count or something like that on my page. And what we do there is we just take the event that comes back to our client from the cluster, and we transform it into a vote that we fire out into the application context in the Spring container. So we just basically, it's just a translation. The event comes in. We could have done some processing here or some transformation here, but ultimately what we wanted to do was actually fire another event across the application container so that other application components could respond to it, like maybe a model, a view, right? Maybe another service might want to send that data somewhere else. So it gives you the option to do that. And essentially, this isn't you asking for the data. This is the cluster telling you when something changes, right? Which is very powerful. And that's, again, you can express that with a query.
So a small update, John.
Yeah.
Enough people were voting that our free Postgres database got crashed. So had we had the cacheable at the start, people would still be voting. So now we'll never know who the best hero was.
Oh.
We should have started with Geode.
We should have.
Free database.
Shame on us. It's not to say that all databases won't, be able to handle load, obviously, but there's certainly a lot more work involved in trying to scale up a database, right? Especially if you start looking at partitioning in a database, like that's a really complex thing to do. I personally haven't done the actual administration of doing something like that, but I've worked with a lot of DBAs who have, and it's quite a ceremony, right? Like you have to have different drivers and different types of connection pools to be able to like efficiently get your data and all that stuff. So I just ran the test for some reason. I meant to run the application. My apologies. Let me do that.
Test passed. That's good.
Yeah, yay, green. I love green tests. Again, it's all about trying to make this stuff easier to do. And there's even test facilities that are in this repository that you can see. We're not going to actually talk about those today, but we have written tests for this that use the Spring Test project for Apache Geode and PCC, which tries to make your testing for distributed style applications easier to do, starting things up, putting data into and out of that cluster, being able to assert all that stuff that it's valid. So there's frameworks that go along with the SpringBoot project that really tries to complement your end-to-end development experience. So now our application's running. This is with Apache Geode. We're going to come back to this in a minute because I just want to show you that this CQ is going to fire. So here's evidence that my application started up. All right. Over here in my browser, can everybody see it okay? Good. Oops, here we are. So this is a previous incarnation. Get there. All right. So this is my machine, so we kind of have to start everything again, but we'll do that quickly. We'll create a couple characters. Great. And then we'll create a battle. Test. And we can vote on something. Let's vote for A, and we can blow up. Oh, I don't have a cluster running currently, so this actually expects it to connect to something. Let's do that. We'll actually get to begin to see some of the power of this cluster.
This has been the story of the day for us.
My apologies in advance. Ta-da. So I have a script, fortunately, that makes all this easier to do. All right, let's do this really quickly. I'm really anxious to get to the other thing that I want to show everybody because I think that's really exciting too. All right, this is Jumpfire. Here we go. Gfish. All right, so this application is, in fact, expecting to connect to a cluster. So that's exactly what we're going to do.
You're starting up a cluster right now.
Yeah, so this is just being in my local development environment. Like I don't have to necessarily deploy something into a managed environment to use it. Like I just want to test out some things locally. So that's what we're trying to do right now.
And this cluster has your function inside of it.
Yes, it will deploy the function. In fact, we're deploying it
doing it right now.
now.
Kind of. So list members, these are the members of the geode function. So one locator, one server, list regions.
So we don't have any regions yet. So we're going to show you a magic trick.
Okay,
We do
so
have
there's
our
your
function.
Cool.
All right, so let's restart our application. Let's try this all over again. Hopefully my typing skills are up to par. Recycle this guy. So JPA is still in the background. There is a database. In my local case, I'm just using HSQLDB. I actually had it connect to Postgres as well, so I also have Postgres running. But when I start running a lot of things on my machine, then my machine starts to melt and heat up, and I don't want it to blow up. So for now, we can go back to the application. Just now it's running again.
You have to recreate those super creative characters you made.
Yes, I know. A and B.
We need to know who will win,
Why?
A or B.
Yeah, exactly. A's going to win because I'm going to make A win.
know.
You don't know? Okay. Oh, no. Delete that guy.
Yeah, get rid of that.
I typed too fast. B. All right, let's create a battle. Again, new battle test. All right, vote. A. A's my friend. All right. So what happened on the back end? We didn't even have a region to put this data in the first place. Yes. Sorry, my apologies.
What? There's regions. Where did those come from? It's magic.
Our application told the cluster what it needed. So one of the things that the SpringBoot for Apache Geode project and PCC does is it tries to inform the cluster what you need from your application without you having to do it, right? We want to keep your focus on building applications and services, not on like infrastructure and plumbing. Like you add a region, maybe you add 100 regions. Like you think about databases, right? Like I worked on databases that had hundreds of tables. Imagine like having to do that every single time. Of course we scripted that, but not only do you have to do that from the server standpoint, you have to do it on the client. So the framework's actually managing some of this for you. So it's looking at things like, you know, if we look at our battle service, for instance, where'd you go, battle service? There you are. All right. You see these cacheable annotations. It's already defining the caches that we need by our application. So as the application is starting up and bootstrapping, it's looking at those things, it's inspecting your application context, and it's figuring these things out. Hey, your application is going to need a cache. We're even going to do some more smart things around functions that I'm not going to talk about today, but essentially anything that's an application concern should be something that the framework handles for you, regardless of context, whether you're in a managed environment or unmanaged environment. So that's why those regions showed up. The other thing that we can take a look at here is that when I voted, got to remember what my log message was. Let's see, let's go back to the application component that had that. Logging, event adapter, and it was, so I logged this out, user voted, so it's fine, voted. Oops, wrong one, space. Fine, voted. Wrong, did, there we go.
Voted.
Client votes. Did I say
D.
S?
Make it a D. Voted.
My bad. All right, there we go. So unfortunately, we didn't get time to wire this to our UI, but we very well could have. And we've done that in past examples where we actually tied the CQ to a WebSocket that then fed the UI or could feed something else asynchronously, right?
So I got an object back from Gemfire based on an event.
Exactly. So when I voted, that went into the cache. That generated the event that triggered our CQ in this application component, which we registered on the event handler method. And all I had to do was actually name the CQ. They have to be uniquely named, of course. And I just have to express the information I want back. And I do that with a query. And the OQL language, object query language, is very similar to SQL in the sense that, you know, you have your same clauses. You can select your projections. You can add predicates and filter and group by things, right? So very intuitive. And then once that CQ triggers based on data going into the system, it feeds the clients that are interested in that information. And you can respond to it however you want. In this case, we're just outputting it. But that basically showcases the 3 different things that we kind of talked about from a cloud-native data access pattern standpoint. Caching, simple to do, right? You just focus on where you think your application needs caching. The framework will take care of the rest. Put that information in there. Distributed compute, right? There's a lot more things that go in distributed compute in terms of like the type of functions that you might write. It's very application-centric, but it's in Java. It's distributed. You can enrich your data. You can aggregate, bring that all back, and you might be able to respond to it in some way using like an event query. So that is our application in a nutshell with Apache Geode in the mix. Again, this would work in a cloud-native environment using something like PCC, which would manage all the infrastructural things like scaling out your application to make it more resilient.
Let me show a Geode option deployment, and then maybe you could show PCC.
Yeah, so we got, it's 2:48, so we have what, until 3:10?
Yeah.
Yeah, I have one more special demo I want to show everybody.
Please.
But if you want to do this now, we
this
can
will
do
be
that.
fast.
Okay.
Yeah.
Switching a couple more
So
times.
here's some pain that we went through today, and I'm sure some others have gone through. And normally this is what, the 6th time we've done this talk?
Yeah.
Normally we always come out the other side of this, but this was like a rare day where we didn't get things working. But I'll show you what we did get, and John can tell you how no one will have to suffer this pain again. So this is AWS console. You'll see I have a number of Geode. So they're just EC2 instances, T3A mediums. So you can see here we have a very small cluster running. So we've got 4 members, 3 servers, 1 locator. Not a whole lot of memory. We had some sort of networking configuration challenges with AWS. So really what I had to do to kind of get this hooked up to the version running in PWS is upload a lot of stuff. So I had to get all the Geode binaries up there. And on top of that, I brought in some scripts. And these are scripts I can remotely call. Let me zoom in a bit. These are scripts I can remotely call to start the members up, and then I have to configure the members to know who the other members are on AWS, and you've got to deal with public DNSs and all sorts of things, and then you go to Azure, and it's a whole other thing. So, I mean, we got it going, and then to connect to it, all we need to do is set this great little configuration. You can see that data, Gemfire management, HTTP, pool locators. So I just put that AWS locator, and then when my app starts up, it connects to the cluster, does all the magic that John was talking about, and we're hooked up to a cache. It was really painful setting up this AWS instance. We decided to update the version and the scripts that we used from last year, and there were all kinds of problems. So John, if I didn't want to have to become a Gemfire master and have to escalate to engineering to get this fixed, is there some way I could get a cluster?
Absolutely.
All right.
Let's take a look at that. So, something that's relatively new and I'm very excited about, especially to share with everybody today at our special time of year to be able to do that, is something else that's going on within the Spring ecosystem for...
Plug in here.
Oh, yes. Yes.
Can
you all see that?
You're the only one who can see.
Perfect. All right. No more sound. Not to worry about sound. Okay. So right now we're busy trying to create a project page for this new project, SpringBoot for Apache Geode and PCC, but it's on GitHub under Spring Projects. Oh. So this is the SpringBoot project that I was just referring to, and it's under Spring Projects, SpringBoot Data Geode. I'm not going to get into the history of the naming, but essentially this project lives here, and most of the information lives here. I actually tried to create all the relevant documentation, Java doc there, so that you have one place to look at it. This is what the guide looks like. There's a whole bunch of samples there. We're actually going to walk through one of those samples today, essentially getting started with SpringBoot for Apache Geode. We're going to go from local all the way up to PCC, and we're going to see how easy that is to do. And if you want to see the content for this, all you have to do is read this guide. There's actually example code that goes along with it. So back in the samples, the source is here. The guide is on the left. So we're just going to reproduce that. And we're going to do, as Josh would instruct us to do, we're going to go to start.spring. I'm going to type this.
Josh is way better
.io.
at typing it.
He's had way more practice. Yeah. He's also a better typer than myself. So we're going to generate a project here for Apache Geode. It's going to be a Maven project in Java, of course. We're going to use the latest version of SpringBoot. Group ID, doesn't really matter. Example demo. I am going to change this just for my own purposes. Example app.demo for the package name. And of course, we need to add a dependency. So we can just say geode. And we can click on that and add it. You can look at what's in the project simply by hitting Control Space, and it'll show you the POM file. It essentially adds the Spring Geode starter, org Spring Framework Geode, Spring Geode starter. Okay, so we're going to generate that project. It's going to download to my file system. I'm going to actually stick that in. I think that's the right place. Save. Okay, doesn't really matter actually. I'm going to go to my file system really quickly. I'm going to open that zip file. I already have it focused somewhere. There we are. Demo zip. Let's open this up. Let's double click on this POM file. And that's not what I wanted to do, of course. Open with IntelliJ. Other. All right.
Yeah.
All right. So now we're going to start a new project that has literally nothing in it other than a SpringBoot class. And it also, of course, has our SpringBoot for Apache Geode project on the class path. That's literally right here. And we are also using the latest version of SpringBoot, so 2.2.0 RC1. SpringBoot for Apache Geode is lagging behind by one major version, but the minor versions will always sync up, as well as the release candidates and milestones, of course, from this step forward. So if we look at the application, nothing really interesting there, but it is runnable. So it's a SpringBoot application, and we can run it. So let's do that real quick. And I promise to be as fast as I can to hopefully get you to where you're going next. So, okay. What's interesting about this output, however, is that in addition to starting up SpringBoot, right, there's our SpringBoot 2.2.0 RC1, it also started Apache Geode. And it's using a relatively recent version, 1.9.1. The latest is 1.10, but this version of SpringBoot is based on 1.9.1, predominantly because that's the version that SpringBoot pulls in from Spring Data. So it actually started up Apache Geode and did a bunch of initialization and then just exited because there's nothing to do. The application doesn't do anything yet. So let's make it do some stuff. So we're gonna just, probably the most interesting thing, or at least the place where most people start is, let me just see if I can put something into a data store and get it right back out right away, right? Like this is to make sure that works. So let's create a customer class to model that. So we'll create a model customer. And all we're going to do there on our customer is we're going to say that it's going to go to a particular region, customers. So this region annotation is kind of the equivalent to the JP annotation to say I want to map that. I want to map that to a region inside the cache. So the cache is, come on, there we go, please work. Okay, we want to map that to some region inside the cache. So the regions are really equivalent to tables. So we're going to give the customer an ID, private, long ID. And we're going to say that it's the ID. So this is the Spring Framework annotation for @ID. And we're just going to name our customer. We're also going to say that these things can't be null, so non-null. Before I do that, I'm going to actually use another library, Lombok, to simplify things. Some people don't like Lombok, some people like Lombok. I like Lombok for demoing purposes and testing purposes. Beyond that, I don't generally use it, but it's really up to you. Org.project, Spring project, Lombok. There we go. All right. So now we can actually add this and get the right annotation that we're looking for, which didn't show up yet. Why not? Maven, refresh that. Demo, dependencies. Okay. There we go, Lombok. Perfect. And we're going to say that this guy is non-null. I also want to say at required args constructor, static name. And this is just based on some code that I'll generate in a minute. So I'm not going to type everything. All right, so we have a basic object, model object that we just want to persist into Geode and get it back out. So let's create a repository to actually do that. New, child class, and call it customer repository. Repo dot, and this will be an interface that will extends the CRUD repository. Okay. The other thing I want to do really fast so that it doesn't triage my demo is I want to stop this last cluster that we were using. Okay, good. Still plugged in. Stop server minus name equals server 1. And I'm going to stop the locator. Okay. I'm going to blow away those directories too. Okay, now back here. So in our CRUD repository, I'm just going to add one method, finder method, query method. I'm going to say customer find by name like, customer find by name like string name. So then I can do wildcard searches. And then we need to make our application do something somewhat useful. So I have already a runner that I generated. Customer runner, and all it does is do some assertions. So I'm going to bring in another dependency for assert_j real fast. Assert_j core, in fact. Yes. All right. So then walk through this in just a minute. Let me get rid of that. There we go. Refresh. Okay. Port static. There we go. Assert_j core. Perfect. All right. So it might be complaining about, oh, well, actually, should complain about that because we haven't actually done everything with Lombok just yet. So let's just make this data. So that gets our getters and setters there. So it should be fine now. There we go. Oh, I didn't type my repository, of course. I must do that. Jumping around too quickly. Customer long. All right. All right. And now we're back in business. Now, I don't have a cluster running. I don't even have really much of anything yet. So what would happen if I ran this? Oh, well, while that's running, basically what I'm going to do there is I'm going to make sure that the cluster doesn't have anything in it. I'm going to put a customer in there and save it. And then I'm going to query for that customer by a wildcard. And I'm just going to assert that my customer is equal to what I put in. And of course, it blows up because I need some place to put that data. Right? And there's a lot of different ways in which you can create regions. And we don't make any assumptions about that because the setup can be actually rather complex. You can have eviction and expiration policies. You might store stuff in off heap. You might have a lot of different ways to configure a region. But if you just want to do that simply and very quickly, then all you really have to do is, well, if I'm using the repository abstraction, I can say enable entity defined regions. And I can give it the location of where my entities are. So we kind of want to limit that scan. We don't want it to go wild and scan all the classes. So I can just give it a base package classes and give it my customer class and say, find all the entities in this package. So it uses that class as a reference to say, what is your package? I'm going to scan from that package down into the sub-packages. So that just gives us our region. Now we don't have to worry about creating the region. We don't have to worry about what that region definition really looks like. I just want to stick something into the region, into Geode as quickly as I possibly can. Oh, there's no servers available. So by default, it wants to actually put this information somewhere, right? It's not going to do it locally. It's assuming that you're in a client-server model, and it needs to have a cluster. But we're not quite ready to do that yet. So let's make our application a little bit smarter and say, enable cluster aware. Now if we run it again, hopefully it should work. All right. You can ignore this exception. That's just basically trying to pre-fill the default pool. But you can see that it actually logged our information. Our runner ran. The application works. It runs locally. And I have some very powerful primitives to actually make that a reality without actually having to do a lot of work. Like, I don't have to stand up a whole cluster first to put my data there. I can just start developing this in my IDE. I can actually debug this in my IDE. It's real simple to do. But at some point, it's not really useful to have all that application data locally, right? Like, I need to put it somewhere. I want to put it up in, say, a client and server. So let's go back to gfish and let's actually start that up. In 6 minutes, okay. All right. So let's start a locator. And it goes to locator 1. Now again, this is all in that guide, so it kind of walks you through that, but I really wanted just to show everybody that today, the power of this. Start a server. So the locator is really just a way for clients to find a cluster of servers and for members to join the cluster, like to scale your cluster out. So that locator is like a location-based service. Well, it is a location-based service to allow you to do that. Goes server 1. Okay. So we'll have our 2 members here after this starts up. List members, and we have no regions. And now what happens when we run this again? We hope to see the same results, but in a different context this time. So now we do. The application ran, so it saved a customer. We queried for it. We got it back out. It was the same. But this time, it actually connected to the cluster, and it created that region, and it actually put something into that region. So I have one entry there, and I can actually query it, even inside of gfish. Select c.id, c.name from customers, c. And there's our John Doe. I didn't have to change any code or configuration. All I had to do was specify a few primitives, annotations, some primitives to enable it to, oh, there's a cluster available now. I'll connect to that, and it'll use that cluster. And if I stop this cluster, it'll just go back into local mode and work as it did before. You don't have to think about that context switch. The final thing I want to show you is the PCC bit. So once I've got this thing running and working locally, I probably want to put it somewhere. Where's my browser? There we go. Okay. So we're going to go up to a PCF environment that I actually control. Yeah.
While John's doing that, I was talking about some of the pain and complexity. I mean, Geode is an awesome tool, but it's super powerful. It does a lot of things, a lot of configuration. So if you're kind of new to it, or you haven't worked with it in a while, it can be a little tricky. And that's sort of what I suffered a little bit today with my scripts. What John's showing here is a real easy way to get going and productive with it quick. So he's about to show how to get a cluster on demand, which is amazing. And then, of course, I know all those annotations are really cool.
Indeed. So now I want to push this application up to Cloud Foundry, and I want it to just work. So we need to go back to the CF command line, or our application. Change directory to, okay, temp. Yeah, I guess it was okay. Change directory to demo. Maven clean. Install minus package, actually. Just package it up. Skip the tests. And just go. All right, let's blow this up a bit. Okay. So now we should have an artifact that we can push. CF push u, so no validation. And we'll start it up manually ourselves so we can see actually what happens. We'll start and target demo. I don't even really need to do that, actually. But I do need to create a manifest file. Actually, just remember that. So I need to tell where this goes. Unfortunately, I already generated the manifest file. So all I do is got to say manifest YAML and say demo manifest. All right.
Wow.
So this just tells it to use the build pack to connect to my PCC1 service, which we'll take a look at as we're pushing this. Hopefully that pushes without incident. And we'll come back here real quickly. So if we go into my org and space, I actually have a PCC service. I have a couple different services, but I have a, oops, sorry. I'm going backwards. Need to go forward. There we go. So we have a PCC1 service there that you can see. When this app gets deployed, should connect, should deploy and actually bind it to the PCC service.
So what did you have to do to create that service?
So all I had to do was actually go into Apps Manager, actually search for the Pivotal Cloud Cache Service instance, and install it. And then it'll create an instance for you. You can select the plan size that you want, and then you have that service immediately available to you to use for your application. All you have to do is basically make the association. And the SpringBoot for Apache Geode project works for PCC. It'll detect that there's a PCC environment available, connect it up, and actually start using it. And there's a lot more that actually goes on there. Some of the things I didn't actually show you was what happens when serialization isn't enabled, right? It wouldn't be able to actually serialize our customer type because I didn't actually implement Java IO serializable, but it's sending it between the client and the server. So that type most definitely has to be serializable in some form. And this framework is already handling that for you. Okay, so it looks like it deployed. Let's go back to my thing and look real quick and see. Whoops. Going backwards again. Playground. Oh, and it already ran. How about that? Actually, it should have
Look at the logs.
crashed, yeah. Just because I didn't actually block it, so it actually should just stop right away. But so it might be actually in the process of recycling it. But we can actually connect to this particular server. Just looking for the output of the application to spit out in the logs. I'm not seeing it yet.
Clicks tail at the top.
Oh, yeah, my bad. I always forget to do that. Yeah, so head and exit status. Search in there. Oh, and okay, so I need to connect. So the application crashed only simply because there was already data there that I apparently didn't clear out the last time I ran this, and I apologize for that. Actually, we could literally, well, let's do this. Unfortunately, that region exists too. Let's go here real quick. Promise this won't take much longer. Actually, now that our app is bound, I might have to get the specific connect string. So we can actually connect to our PCC service instance outside of Cloud Foundry itself. So the way we do that is we can go to the app. Where are we at here? Demo app. Okay, so it said it crashed. That's fine. Settings. And here we go, real environment vars. So if you look at this information, it gives you a connect URL that you can use to actually connect to your PCC cluster from gfish. All right, and we're going to do that fast. Gfish. Okay, connect. Whoops, I didn't get everything apparently. There we go. Copy, paste. Boom. And we can just blow through that real quick. We can see our members, list our regions, and of course we already had one, so let's destroy that region. Just name equal customers, list regions. Okay, and the other thing I want to do real fast in my app, which is to block, which basically just adds a scanner to wait for input so that we can see it run and not crash and constantly try to restart. We can actually re-push that real fast. Even package that, push it, and we should be in business. Of course, I'm not sure what I actually tried to start when I told it not to. No start. Oh, that's because my thing didn't have that. Okay. Actually, what I'm going to do real fast while I'm here is just blow this away and start completely fresh. So we go to settings, delete the app. Delete. Okay. This is the last bit, I promise. It's deleting, gone. Push it up there one more time. Hopefully this is quick. Set the flag.
Where they're going to pull out one of those canes with a hook soon.
Okay, my app should be there. Refresh. Demo. Start this up. Go to logs. Tail it. And the moment we see some red happening, we're in business. Go through the staging process, and then it's going to connect the service, and everything's going to start running. And in the meantime, let's come back here. Shouldn't have anything. Oh, there's our region. So it actually, the app's already starting up, and its chances are it already put data there. Usually it shows up in red. Well, we can describe it over here. There we go. And we do have data. And if I queried it, it would be the same John Doe. So
you got a cluster, you got all configuration for free, and you're able to write to it.
Yep. So this framework provided all that information. We'll stick around afterwards if there's questions. Thank you very much for all your time today. I know it was a long day. And enjoy the rest of the conference. Thank you.